Alright, so this next problem is asking us to find two numbers that have a difference of 13. When we add the squares together, it yields a minimum. So we've seen the whole idea of adding squares together in an earlier example in this worksheet. And again, we just need to define our variables first. So we're looking for two numbers. Let's just call those numbers a and b. Okay, so once we define those, again, we know we're trying to add the two squares together. So it means we're going to have the equation a squared plus b squared. What's that equal to? We don't know. Let's just call it something. Let's just call it s for sum. And we're trying to make this a minimum. So again, whenever you see the word minimum, you're trying to think something to do with the vertex. And it's not asking anything to do with what the minimum actually is, just wants to know what numbers will create the minimum. So you're going to be looking for the axis symmetry. But again, problem that we've seen far too many times now in this worksheet is that we have too many variables over here. We have to try and eliminate one. So the information that we haven't used yet is we were told that the numbers have a difference of 13. Well, what does difference mean in math? It means that one is 13 larger than the other. So let's just say we let a be the larger number. We're going to have the equation a minus b equals 13. Okay, and that's going to be an equation that we can then use to isolate for a variable, which we can then use to replace a variable in our main equation over here. So the easiest one to isolate for is probably going to be a, just a matter of adding b to both sides. So a is going to be equal to b plus 13. Okay, and now we can make that substitution into our main equation over here. So you wind up with b plus 13 all squared. Then the rest of the equation stays the same, so plus b squared equals s. Okay, so again, this isn't in any kind of form that we recognize, but if we do expand everything out, we can put it in a standard form. Then we have ways to find the axis symmetry once we're in standard form. So we're going to expand out b plus 13 all squared using an array. Okay, I'm not going to go through the entire step of expanding and simplifying. You should be able to do that by now. Okay, but remember, just set it up with an array. It's b plus 13 times b plus 13. You should wind up with when you're finished, b squared plus 26b plus 169. Okay, and we still have that plus b squared in here, and that's going to be equal to something that we're going to call s. Okay, so all that's really left to do is to collect your like terms together. So our b squareds are going to add together, so we get 2b squared plus 26b plus 169. Okay, so from here, again, if we're looking for the axis symmetry, we can try and find the zeros if they exist. I'm not sure if they do. We could always check the discriminant. We could try and complete the square to put into vertex. Remember, we could use partial factoring to go into partial factored form, then use symmetric points to find the axis symmetry. But again, the fastest way going through this is just to use the fact that the axis symmetry is going to be equal to negative 26, which we call negative b, all over 2a, so 2 times 2. So we get negative 26 divided by 4, which is going to be negative 6.5. Okay, so that gives us one of the values. So we know b is equal to negative 6.5, so we still need to find out what a is equal to. So remember here, we saw that a was equal to b plus 13, so let's use that equation. So we're going to put our negative 6.5 in the equation for b, which then, when we finish simplifying that, gives you a is equal to positive 6.5. Okay, so which two numbers that are 13 apart from each other give you a minimum when you add the squares together? Well, it's going to be a is equal to positive 6.5, and b is equal to negative 6.5. Okay, so let's move on and try another one. So the altitude of a triangle, so the altitude meaning the height, okay, just get used to that terminology, is 2 meters longer than its base, where the dimension of the altitude and the base if the area of the triangle is 40 square meters. Okay, so let's draw out this triangle. It doesn't say what kind of triangle it is, if it's a right triangle or not. You can't assume it is. Let's just draw out the triangle. Okay, so what we know here is that we have a height. Okay, and we know that this height is going to be 2 meters longer than its base, and this over here is going to be the base of the triangle. Okay, so obviously it isn't drawn to scale because the altitude is longer than its base, but we know if this is our base, our height should be equal to the base plus 2. Okay, And again, that comes from the fact that we're told that the altitude of the height is 2 meters longer than its base. So whatever the length of the base is, add to that and you're going to get the height. Okay, so it asks for what the dimensions are if the area of the triangle is 40 square meters. Well, again, how do you find the area of a triangle? Hopefully you remember that the area of a triangle is equal to half times the base times the height. Okay, and we know that the height is going to be equal to the base plus 2, so it's going to be half times the base, and we're going to replace the h with b plus 2. Okay, and the other thing that it tells us that the area is actually going to be 40 square meters, so we can put that in for the area. So what we actually have here is a quadratic equation. Okay, as messy as it looks, all we have is an equation that's factor form on one side, not 0 on the other. But how do you solve any quadratic equation? Well, you have to bring everything over to one side and have it equal to 0. And then once it's in a form you can recognize, you can do some work with it. So what I'm going to do here is actually expand everything out here. So I'm going to leave the 40 alone on the left for now. I do eventually have to bring it over. I'm just going to leave it for now. So I have half b. I'm going to multiply that into the bracket here using distributive property. So it's going to give me half b squared. And then half b times 2 is just going to be 1b. So I have half b squared plus b equals 40. And then I'm just going to bring everything over to one side by subtracting 40. Okay, so that's going to give me 0. And I have half b squared plus b minus 40. Okay, so what I have here is a quadratic equation. It's equal to 0. So my options here are to either use the quadratic formula to get my solutions, or I can simply try and factor it. So I'm going to check the discriminant to see if it factors, because again, if it factors, it's always faster, in my opinion, than quadratic formula. If you prefer to use quadratic formula, feel free to from this point, but we should wind up in the same place in the end. So I'm going to check my discriminant here. So b in this case is 1, so I have 1 squared minus 4 times a half times negative 40, which gives me 81, which is of course a perfect square, so this does factor. Okay, so to factor this, I'm going to try and look for a greatest common factor. Again, it looks kind of complicated with that a out there being a half, but I can still factor out that half as a common factor, because all I have to think about is, well, if I'm going to factor out a half, I'm going to be left with b squared here. That part's easy. But how many times does a half go into 1? Because this is 1b here. So a half goes into 1 twice. So I'm going to have b squared plus 2b. Okay, and how many times does a half go into minus 40? Well, since a half goes into 1 twice, it's going to go into 40 80 times. So I have minus 80 here. Okay, and the other way you can think about that is 1 divided by a half is 2. 40 divided by a half is 80. So that's how I get what's there. So what's left over here, b squared plus 2b minus 80, is actually a simple trinomial. So I want to factor that. What I'm looking for is two numbers that are going to multiply to negative 80, but add to 2. So those two numbers are going to be positive 10 and negative 8. So I'm going to get 10b in here, negative 8b in here. Okay, so what I wind up getting as a factored form is b minus 8 and b plus 10. Okay, so from there it's not too bad to get my zeros. You just need to look at each factor. So I get solutions as b equals 8 and b equals negative 10. Okay, now I was about to ask myself, are all these answers valid? Well, b equals 8, sure, I see no reason why I can't have a base of 8, but I can't have a base that's length negative 10. A negative length is not possible. So right away from here, this is invalid or inadmissible. Okay, so that means the only value you can get for my base is 8. So if I know that my base is 8, what's my height going to be? Well, I know that my height was going to be equal to b plus 2. So 8 plus 2 gives me 10. Okay, so the base and height, they give me an area of 40 square meters, is going to be 8 meters for the base and 10 meters for the height.